let's get a little bit of a warm up. I want you to work with me. It's tough that you don't have a hard copy in front of you. So let's look at 2.1, the first question. How would we find A?
360 degrees subtracted by all the other
Well
angles.
done. Okay, so we can see that's a quad. All angles in a quad must add up to 360. So if we take 360 minus the remaining three angles, what do we get actually? Nobody?
50 degrees.
How many did you get?
50 degrees.
50 degrees. Are we not in agreement there? And what would your reason be there?
Some angles of a quadrilateral.
Some angles of a quad. Well done. We're moving on. We're going on to 2.3. I'm going down the line, okay? 2.3, you'll notice that we have two dots there. That two dots means that that angle there is bisected. So we should get a 45 and a 45, okay? And how would we find B?
It would be a 90-degree angle.
And what would be my reason? Some angles of a triangle. Okay, we're going to go to 2.4. I'm going to skip the other one. I'm going to 2.4. You see parallel lines, okay? As soon as we see parallel lines, I'm just doing a warm-up session before we go into grade 10 proper geometry. When you see parallel lines, there are three things that should be coming to your brain. It should be racing, alternate angles, corresponding angles, and you should be thinking co-interior angles are supplementary. So we know alternate angles will be equal, corresponding is equal, co-interior angles should be adding up to 180 degrees. So let's get to our diagram. How would we find A? Somebody? Anybody? Nobody?
Some angles
so-
of a triangle.
So
Yeah.
it will be 25, won't it be? So
25. How did you get
given.
25, young man?
It's given. They have the 2 marks there.
I can't see 2 marks there saying given. There's no word called given.
So some angles of a triangle.
Well done. I drew the green triangle. Can you see some angles of a triangle? 180 minus 80 is 100. 100 minus 58 is 40. Sorry, I said 100 minus 58 is 42 degrees. Am I correct? You can talk to me. Am I right? Am I wrong?
Yes, sir.
Okay, we're moving on. Then we want to find, okay, let's try and find C. It seems to be easier. How would we find C? And I want to give you a hint.
Alternate angles, sir.
Well done. Alternate angles. A and C are equal. They are alternate angles. Did everyone see that Z I drew in there? So we got a 42 and 42. Now remember, geometry, we want reasons. So I'm telling you the reasons. Please write it down. I will post a copy of this worksheet up on Teams later. Then we're going to go to B. How would we find B?
Co-interior angles.
Co-interior angles. We can use that. Something simpler. I'm hoping you're going to see something much more simpler than
Some angles of a triangle.
Well done. Some angles of a triangle. Can we all see this triangle? A lovely pink triangle I drew for you there. And what would we get?
110, sir.
Somebody said 110 degrees. A shocking pink. And remember, I'm looking for a reason. What would my reason be for that 100 and... please keep your mics on mute. And put it off, put it on when you need to ask a question, then switch it off again, all right? So we got, how many did we say there? Somebody gave me an incorrect answer, or was it right? 116, did you say 116? Okay, and then we're looking for some angles of a triangle. Now we're gonna go on to 2.5. You see a kite. All right, what do we know? Well, actually, even if we don't know, it's a kite. One stroke means A has to be 25. Two strokes mean B has to be 75. Okay, I think 2.6 is straightforward. It's a rectangle, opposite sides are equal. We're going to skip that. We're going to move on. All right, I'm using my Zoom pen to draw. Now I realize that if I use my Zoom pen, when I'm scrolling up. All right, we're going to look at 2.9. If we're looking at 2.9, let me give you some time. I want you guys to try first, okay? Or think about it at least. We want to find X. Any ideas out there?
M1 is equal to 3x because of alternate angles.
Well done. Somebody told me M1 is equal to 3x. Alternate angles. I'm happy with that. So what are we going to do next?
Some angles of a triangle.
Some angles of a triangle. All right. So if we look at the triangle that is being referenced, let me quickly highlight that. If we take 3x plus 4x, that's 7x, plus the 75 must give us 180 degrees, and that is some angles of a triangle. And if we work this out, 7x is equal to 180 minus 75. That gives me 105. We can now divide both sides by 7, and x is equal to 15 degrees. Are we happy with that?
Yes, sir.
Okay, we're going to 2.10. It tells us it's a rhombus. Now, gentlemen, rhombus is one of the diagrams that it's quite common in exams, and it has a lot of features. So let's quickly write down all the features we know of a rhombus. All right, go for it. Who can tell me the first feature that they know about the rhombus? Or should I say
Diagonal
properties?
bisect at 90 degrees.
Sorry, say that again.
Diagonal bisect at 90 degrees.
Okay, diagonals, I'm going to write that down. Bisect perpendicularly, okay? Now, what does that actually mean? So we go to the diagram. This is what it means. That is equal to that. The diagonals are bisected, and also they're bisecting at what we call a 90 degrees. So all the angles in the center are 90 degrees. Well done. What else we know about the rhombus?
All sides are equal.
All sides are equal in a rhombus. Is that actually true? Yes, definitely. All right. So we know, I'm going to put that in blue. I'm going to put the 3 strokes, okay? Because I've got 2 strokes. So all our sides are equal. Anything else we know about a rhombus?
Opposite sides are parallel.
Okay, it's a palm, so opposite sides are parallel. Can everyone remember that? Opposite sides are parallel. I'll just... One more I'm looking for. And then I'm ready to go into the actual question.
Diagonals bisect the vertex angles.
Thank you. Diagonals bisect the interior angles. Very important one to know. So in other words, B1 is equal to B2, and that happens in all the angles because the angles are bisected. But anyway, let's go to a question. That's what if it tells us it's a rhombus, we have lots of information. Now, the first question is to find angle BMH. They want us to find the whole of angle M. So if we want to find the whole of angle M, let's look at what's given. We can see on the top there that R is 74. If R is 74, then R2 is 74. Because the diagonals bisect each other. And in total, we have 148 degrees. So it means angle M is also 148 degrees. So let's look at some reasons. And if we had to write this down, we're going to say, all right, R2 is equal to 74. And the reason for that, it's a rhombus. And what do we know? The diagonals of a rhombus bisect the interior angles, all right? And then we can conclude that angle M or BMH is equal to 148 because the opposite angles of a rhombus are equal. Remember, it's a palm. All the features of a palm also exist here. So we can say opposite angles of the rhombus are equal. And we know if we split it, each one is actually 74. So we want to get to H2. Any ideas? How can we find H2?
Co-interior.
Somebody said co-interior angle. I like that. But I don't want to use co-interior angles, not that big because it's wrong. I just want to show you another option so that you keep your
Some
options
angles
open.
of the triangle.
Yes, some angles of a triangle. That angle is 90. Let's draw this triangle in. So we can use some angles of a triangle. 180 minus 90 is 90. 90 minus 74 would give us 16 degrees. So we can say H2, but I can't go directly to H2, so I need to call it O1. Let's call it O1. I need to tell the writer that O1 is equal to 90, and that's because it's a rhombus. The diagonals bisect perpendicularly. And from there, I can say, right, angle H2 is equal to 16 degrees. And now we can say some angles of a triangle. Do we want me, is that making sense to you guys? So let's move on. Okay, so I realize now as I'm moving on, I have to erase. Wipe my board out. Okay. I want you to start thinking about these questions that you're seeing there. All right, let's look at 2.11. So we want to find the whole of angle A. It is a palm. Opposite sides are parallel, makes that a parallelogram. So we know immediately if this angle is 35, let's call that A1. A1 has to be 35 degrees. Anyone can help me out there before I go on? What would we do next? Nobody? Somebody? Remember, we want to find the whole of angle A. So we need to find the second part of A, A2. Let's call it A2. No ideas?
Alternate angles with R.
Alternate angles of?
R to get C.
Right, I'm with you, I'm following you. And then?
You can use the C 20 degrees to get R. And then you can calculate some angles of. Now this way is too long. Sorry.
All right, gentlemen, I see sometimes when you look at geometry, you don't see it the first time. So let's quickly go back to the diagram, all right, because there's actually a very easy way to work it out. Let's forget about A1 being 35. Let's take this entire triangle here. We can find the whole of angle P using some angles of a triangle. Would we agree with that? So the entire angle P using some angles of a triangle Work that out. Tell me what would you get?
96.
Sorry,
96
96.
degrees.
So we know the whole of angle P the whole of angle P is equal to 96, and we use some angles of a triangle. Can you see that? So if we know that, let's call it P1 and P2. What would P2 be? It'll be 96 minus 35, which is 61 degrees. And then we can say, right, A1 was 35, alternate angles, and then we can say A2 is 61. And that gives you A to be a total of 96. Or you could have just said, if this whole angle is 96 degrees, then opposite angles of a parallelogram, that'll become 96. But then we have to state it was a palm. Because it didn't tell us it's a parallelogram, we can tell him that AC is parallel to PR and AR is parallel to CP, therefore it's a parallelogram. So let's go to 2.12. In 2.12, we want to find T1. Now they tell us it's a rectangle. What do we know about a rectangle?
Interior angles equal 90.
Somebody said interior angles equal to 90, so immediately I'm going to put there 90. All angles are 90. What else do we know about a rectangle that's going to help us to solve this problem?
Diagonals bisect.
Okay, the diagonals bisect each other, but the diagonals are also equal. In a rectangle, the diagonals are equal, which means these four parts are equal, which now gives you an isosceles triangle. So it means that T1 is equal to R1. So I've got the exterior angle of a triangle to be 112. So I can actually work out T1 and tell him that T1 is equal to 180 minus 112, and we're going to divide that by 2. And what am I using? An exterior angle of a triangle. Are you guys with me there? So what is 180 minus 112? And then we'll take that and divide that by 2. I'm waiting for an answer.
It's 34.
Somebody said
So it's 34, sir.
34. Are we all happy with 34? Can we have someone to confirm that? Then I know you guys are with me.
Right. So
Okay. But the problem is we haven't justified, all right? So we got to tell the writers more, a lot more things before we actually come here. Now, I don't have the space. We first have to tell them that TO is equal to RO. And what's your reason? The diagonals of a rectangle are equal, all right? So we're going to say rectangle here. And the diagonals of a rectangle bisect each other. Another way you can actually work that out is use the straight line and say 180 minus 12 is 68 degrees. And then you can find T1 and R1 using some angles of a triangle.
Sir, the answer is not right, sir.
Oh, the answer is not right. Someone's giving me wrong answers here. You see, I have to work it out myself now. I'm not happy with that, guys. Let's go back. All right. Okay, so what I'm saying is, it's good that I wrote that down. So we are saying that 180 minus 112 is 68 degrees. Okay. Okay, it's my mistake. It's not you guys' mistake. Let me take that out. I think I'm having a little bit of a Let me check that out. There's my, guys, my apologies there. I think I wasn't thinking at the right level there. So if we're using exterior angle, the theorem states that the exterior angle of a triangle is equal to sum of the interior opposite angles. In other words, T1 plus R1 is actually equal to 112. And because T1 is equal to R1, T1 is actually equal to R1, okay? Therefore, we can now say that T1 is actually equal to 112, and we're going to divide that by 2. And if we actually divide that by 2, we should be getting 50. All right, 2 goes there, we're going to go 5, 12, 56 degrees. So T1 should be 56 degrees. And if T1 is 56, R1 is 56 degrees. Are we all happy with that answer? Yes or no?
Yes, sir.
And remember now, we could have used some angles of a triangle. We got our 68, then we're going to take 180 minus 68, divide that by 2. Okay, so we're going to move on now. Are we going too fast, too slow? Are we all managing there? Okay, I'm going to close my document and not use the Zoom annotate, all right? Okay. Any ideas? The first question there, I hope you read the question. Let me read it for you. P and Q are points on the diagonal BC of a parallelogram. I'm going to underline this word parallelogram, all right? That's a very important word for us because if it's a parallelogram, we can now apply all the properties of a parallelogram such that BP is equal to CQ. That is incorrect, all right? The question is, they tell us BP is equal to, that should have been QD. So that just changed. We're going to change that to DQ, which is marked for us. The first question there is to prove that ABP, okay, my line is not very straight there. Let me get that straight line. So first question there is to prove that ABP is actually congruent to CDQ. All right, because of time, we're going to state in triangle exactly what you see here. In triangle ABP and triangle CDQ, we need 3 things to be equal in the triangle, and we must be able to get a case. So who's got number 1 for me? If they're looking at the 2 red triangles, who's got a number 1 for me?
BP is
equal to QD.
Well done. BP is equal to QD. Why is that so?
Given.
given, sir.
We now need a number 2. Can I have a number 2?
BA is equal to CD because of opposite sides of a palm equal.
Well done. BA is equal to CD. And when using opposite sides, that's a symbol for a palm are equal. So let me mark that. So we say that is equal to that. We need 1 more.
Angle
B is
ABP
equal to D.
Sorry.
Angle ABP is equal to angle QDC because of alternate angles.
So let's call it B1. We're allowed to do this as long as you write it on the diagram. We're going to say angle B1 is equal to angle D1 and equal alternate angles. And we're going to tell the writer as well which lines are parallel. We're using AB is parallel to CD. So therefore, we proved congruency. Triangle ABP is congruent to triangle CDQ. And what would my reason be?
Side angle side.
Thank you. Side included angle side. And there we have our first proof on congruency. So congruency is very important. Remember, we have 4 cases of congruency just for revision. It's SAS, triple S, RHS, and what's the last one?
Sir.
Angle, angle, side, or side, angle, angle. Okay, I think we proved that very well. Let's go to the second part. The second part is to prove that APCQ. So I want to firstly highlight that. So for me to highlight that, I'm going to go to APCQ. So we're going to prove that is a parallelogram. Now, what makes a palm? Before we do this question, just part of our revision, what makes a palm? If any question they tell you to prove something, it's a palm, what are you trying to look for?
Opposite sides are parallel and equal, sir.
So one, we could prove opposite sides equal.
So you could say that the
All right, somebody's told me opposite sides equal. All right, we've taken that. Then we can also say opposite angles are equal. Somebody told me about diagonals. If the diagonals bisect each other, it's a palm. If we have a pair of opposite sides that are equal and parallel, that also makes a palm. And the last one, which comes from the definition, is if the opposite sides are parallel, it's a palm. So the good news is, although there are 5 features, if we want to prove it's a palm, we only have to prove one of this. So if we go into our diagram, if now I go to I'm going to rub that out. I hope you made a note of that. So if I go to my diagram, I need to see which feature can I use, which is the easiest one that I can use to prove that this shape is actually a palm. So to do that, let me go into this diagram. Now, in the previous question, we proved that the red triangle was congruent. So if the red triangle is congruent, we know that PA, and I'm putting 3 marks, PA is actually equal to, so I know this already. I know PA is equal to CQ. Sorry, let me just erase that. So we know PA, sorry, my diagram wants to run away here. So we know the first one is that PA is actually equal to CQ. And why is PA equal to CQ? What reason would you have?
congruent triangles, sir.
Well done, congruent triangles. So now, which will be the easiest one? Now remember, we have PA equal to CQ. That does not make it a palm. The feature is opposite sides must be equal. So the easy way I think is if we go and prove, and if we now take the other 2 triangles, it's not the quickest way. I want to emphasize that, but I think it's an easy way. If I take these 2 triangles here, the one I'm drawing in pink, can everyone see BPC? And if I take the bottom triangle called DQA, are those 2 triangles congruent?
Yes, sir.
Yes. same like how we proved the other one. You see, we have BC equal to AD. We're going to have B2 equal to D2. And we have BP is equal to QD. Sorry, my entire diagram just skipped in front of me now. I don't know why it did that. Strange things happen when you're going online. All right. So we can prove that triangle BPC, and I'm not going to prove it for you, but you can actually. So we can prove that triangle BPC is actually congruent to triangle DAQ. And your reason they would be the same, side, angle, side. Now, if we prove that to congruent, therefore we can now prove, or we can conclude that PC is equal to AD. So if we got PC equal to AD, and we got PA is equal to CQ, therefore we can conclude that APCQ is a palm. And what reason am I using? Opposite sides are equal. You know, I want to say that geometry is very challenging, okay? And in grade 10, the focus is not on grade 9 work. You must know it, but the focus is on proving and working with the quads. In grade 10, that is. Okay, we're going to go to the next question. Right, I think I gave you enough time. Any ideas? Did anyone come up with anything?
Yes, sir.
So if we prove ZRW is congruent to YRX, we can say that it has a pair of equal and parallel sides.
So how are we going to do that, young man?
Alternate angles, and they already gave us a side.
Okay. So what are you saying? You're saying prove congruency. Is that what you're telling me?
Yes, sir.
All right. So let's see if you are right. It says the diagonals intersected IZ. Well done. And we know the lines are parallel. If the lines are parallel, we know this angle. Okay, if the lines are parallel, we know that Z1 has to be equal to X1. Alternate angle. So we got a side angle. Yes, what's the third one? Let me write that down. So we're looking at triangle for those of you who are not with us. So we're looking at triangle ZIW. So I'm going to highlight that, and we have the triangle on the bottom. So we need three things to happen in a triangle. So some of you helped me out. You told me right. Number one, Z1 is equal to X1. And we said the reason for that would be equal alternate angles. And ZW is parallel to YX. Number two, can I have a number two?
So ZI is equal to XI.
ZI is equal to XI, and that is given.
Yes, sir.
So what is our number three?
W1 will be equal to Y1.
W1 is
Alternate
equal
angle.
to Y1.
Somebody said W1 is equal to Y1. Are they right? That's equal alternate angle. You are right. What
Yes,
else?
sir.
Beside that, what else? I just want to see more. What else
So,
could we
sir,
have said? Yes.
I1 will
Angle-
be equal to I2 because of vertically opposite
Yeah.
angles.
Okay, let's use that one, all right, because it's different. I1 is equal to I2. I1 is equal to I2, and we're going to use vertical opposite angles. And that now gives us a conclusion that these two triangles are congruent. And which triangle are we looking at? Triangle ZWI. Now you got to have the order right to get marks. You know about that. So if we're saying ZWI, Z1 was equal to X, Y, I. And our case is very important. So we used angle. We used another angle. and we use the side. So we use the angle side case. So why did we do all that? We did that so that we can conclude I just want to change the color of my pen. So we did all that just to conclude that WZ, okay, is equal to that. So therefore, we can now conclude ZW is equal to YX. And your reason there would be congruent triangles.
So
Now-
can you also, sorry, sir.
Yes.
So can you also say the reason is because the diagonals bisect?
No,
Is
it's
it the
not a
triangles
palm.
are-
It's not a palm. You're proving it. Why are you trying to prove it's a palm if you're going to tell us that it's a palm? You can't use that fact because it's not a palm. We want to prove it's a palm. Do you understand the difference?
So I think what
Yeah.
it means is, can we say IW is equal to IY because of
Oh, you
congruent
want to go
triangle?
that way? Yes, we can do that.
Yes, sir.
Yeah, that we can do. We can say IW is equal to I. Actually, that's a very good way. IY is equal to IW, and therefore diagonals bisect, it becomes a palm. But I'm going to use ZW is equal to YX, but we also know that ZW is parallel to YX. What's your reason for this? That was given, okay? And therefore, we can now conclude. Let's go to the question. Therefore, we can now conclude that WXYZ is a palm. And my reason now would be a pair of opposite sides equal and parallel. Are you happy with that? And we could have, if we use the other way, if we went to say, right, YI is equal to, then we would have, our reason would have been diagonals bisect each other. Any questions? Let's move on. Okay, this question, I'm going to give you some time. This question here came on one of my tests, I think, and lots of people messed it up. Or was it a common test? Right. So it says MPRN is a palm. PQ bisects, which means cuts in half. We're happy with that. It's marked on the diagram. RQ bisects. If PQRS is a palm, prove that it is then a rectangle. So they are telling us, you know what, giving us some good hope here, that we know that PQRS is a palm. So they say prove it's a rectangle. Now we know for it to be a rectangle, two things must happen. Number one, it must be proven to be a palm, but they told us that, so we can skip that step. Step two, to prove it's a rectangle, we got to prove one angle equal to 90 degrees. So it's quite a toughie actually. To prove that angle to be equal to 90 degrees, I'm going to use the X technique. And I'm going to bring in some letters to help me prove this angle to be 90. So let's call that P on the top to be X. If that's X, that's X. But now we know it's a palm. They already told us the green one is a palm. So if that is X, we know that the angle R in the bottom would be X, alternate angles. Then we got those small two dots. That's Y. Let's call those two to be Y. Now immediately you can see that angle R is actually equal to X plus Y. Actually, I should say SRQ. So if I know that SRQ is actually equal to X plus Y, my entire focus now changes. Can I prove that X plus Y is equal to 90 degrees? So watch what I'm going to do. So if we look at angle P on the top, I want to change the color here. So let's get back on the top. If you look at this angle P, and we look at this angle, part of the angle R, those two angles are co-interior angles. Remember they told us MPRN is a palm. If that's a palm, it means these lines are parallel. Okay, so if the lines are parallel, we can say that 2x plus 2y is equal to 90 degrees. And the reason is very simple, those are co-interior angles. And if we divide by 2, we get x, sorry, not 90, 180 degrees. So if we divide right through by 2, we get x plus y is equal to 90. Okay, now I told the reader, let's put the R1. Okay, R1 is actually equal to x, and that was because of equal alternate angles. Okay, and we could carry on to say them, all right, that PQ is equal, PQ is parallel to R1. So now if I look at SRQ, SRQ is x plus y, but we have just proved that SRQ on this side is actually equal to 90 degrees, and therefore it's a rectangle. Is that making sense to you?
So what would the reasoning be for it being a rectangle?
The reason that it's a rectangle is because I've just proved one interior angle to be 90. They told us it's a palm. All right. So if I prove one angle is equal to 90, and that is my reason, a palm with an interior angle equal to 90.
Sir, could there also be another way of doing it, sir?
Okay, give me your other way.
So if we look at PQR is a triangle. So sum of interior angles of a triangle will give you angle Q.
Which is 180 minus x plus y. Is that what you're saying?
Yes, sir.
Right, carry on.
So if we worked out x plus y to be 90, then 180 minus 90 would have been 90.
Yeah, that'll work as well. So you're going to prove that angle Q is 90.
Yes, sir.
There are lots of ways to kill a cat, all right? So there's lots of ways to do a geometry problem, okay? And sometimes I may do it the first way that's coming to my brain, I'm going to do it. Doesn't mean it's the quickest and the easiest way. As we said, there's lots of different ways now to do a geometry problem. So let's move on. All right, let me give you some times. 8-mark question. I think the diagram is not clear. They want you to find A. So we got a 4A here. B. There's our C sitting here, and there's our D on this side. So this angle that is given here is actually 80 degrees. So I just want to bring that in. So we know that's 4A. This angle here is 80 degrees. That's our C. Okay. So B is sitting right there. And I think we have D on that side. All right, let's try. Let's start. Let's start with A. So what is 4A actually equal to? Can we agree it's 80 degrees? Why? What would my reason be there?
Sides opposite equal angles.
Angles opposite equal sides. Can you see these two are actually equal, all right? So we have a beautiful isosceles triangle, and remember, you're not allowed, they're now being very strict. If you tell us isosceles triangle, Mr. Pillay, we're not giving the mark. You got to tell us angles opposite equal sides. So we get, divide both sides by 4, we get A to be 20. All right, the question was to find A and not 4A, okay? So I'm happy to leave it with A to be 20, but if that's 80, we know this is 80. Right.
Sorry, sir.
Yes.
So do you think B is not supposed to be on the inside of the triangle, sir?
Well, it doesn't matter. Let's use it as it is, okay? Wherever it is, it doesn't matter. If we're inside, we'll find it. If it's outside, we can still find it, okay? If it's inside,
Yes,
it's
sir.
actually quite easy. Some angles of a triangle.
Yes,
Right.
sir.
So we're going to say in my question, let's refer to my question now, right? You can't change my question, young man. If I got the B outside, we're going to go with that, all right? So angle B is 160. Why is angle B 160?
Exterior angles of a triangle.
Well
Yeah,
done.
angles.
Exterior angle of a... Or you could have went and found the inside angle. Use some angles of a triangle. 180 minus 80 minus 80 is 20. And then you could use some angles of a triangle. Oh, sorry. Some angles of a triangle finds a 20. And then you could use angles on a straight line. 180 minus 20 is 160. So we could go with that as well. Now we're going on to the next question. They want us to find C. Can someone give me an answer for C?
C's 100, so
How did you get 100?
so I said co-interior angles, so and now in angles on a straight line.
Co-interior angle. You should have said corresponding angles. The inside
Corresponding,
angle is
sir.
80. Corresponding, am I right?
Yes, sir. My bad.
And then we go 180 minus 80 is 100. And then we go to D. To find D is quite straightforward. Angles on a straight line. You'll take your 180 minus 80 and that'll give you the 100 we're looking for. All right, that was quite a nice calculation question. Let's look at this question. The figure shows AB is parallel to CD. With the bisector CAB, what is a bisector?
A line that cuts another line in half. So
But in this case, we're talking about an angle here, young man. It's a bisector of CAB, which means A1 is equal to A2. It bisects means it cuts the angles into two equal parts. Are we all happy with that? And ACD. So they're basically telling us now that that is also equal to that. Prove that AE is perpendicular to CE. What does that mean to you? Simple maths. What are you trying to tell us?
That's 90 degrees. So
Well done. They're trying to tell us prove that angle E. We want to prove that angle E is actually equal to 90 degrees. So in a question like this, we've got no measurements. You must bring in your X. So you start off saying, all right, let's A1 will be X. So A2 will be X. Why would A2 be X? What reason would you say? So remember, you can start off by saying, all right, let A1 equal to X. Why would we call A2 X?
given, so
Okay, given, bisected, all right? Then come to the bottom, C1, you bring in a new letter. Let's call that Y, and that's Y. So what is the angle E actually now equal to?
$180 minus X plus Y.
Yes, well done. 180 minus the X plus Y. Why would we say that?
Some angles triangles.
Some angles of a triangle. Now, then our entire focus now will change. Can we find X plus Y? So we need an equation to find X plus Y. Look at your diagram. Is there any equation that will help you to find X plus Y?
2x plus 2y is equal to 180 degrees.
Well done.
Co-interior angles.
We use co-interior angles. Can you see that? Just like the other question. 2x plus 2y is equal to 180. And if we divide by 2, what do we get X plus Y to be?
90.
If we're saying 2x plus 2y is equal to 180, that's co-interior angles. Divide by 2, we get our X plus Y to be equal to 90. Then if we put that in here, you get your angle E to be 180 minus 90, giving you 90. And we solve the problem. Are you happy with that? All right, no questions. We're moving on. Let's give you some time. It says now the diagram below shows a rhombus. Now remember, we spoke about the rhombus earlier, so we're not going to go and talk about the properties. Gives you the diagonals. Q1 is equal to 38. Calculate the values of X and Y. So anyone got an answer for X?
38, sir.
38. What reason would you have?
Diags bisect vertex angles.
Well done. If ever you're confused and you can't remember the reason, just write rhombus, okay? Now, we got T1 is 90. Why is T1 90?
Diags of rhomb intersect at 90 degrees.
Well done. I said if you're confused, can't remember it, put rhombus. If you can remember it, it's fine. Now, we can find y. What are we going to use to find y?
Some angles of a
angles of
triangle.
a triangle.
Some angles of a triangle. 180 minus 90 is 90. 90 minus 38 is 52 degrees. Are we happy with that? So we found our x and we found our y. I'm quite happy with that, to be honest. Okay, there's a second part of the question now. It tells us that PA is equal to 2A. Now they're talking about the sides. So PA, I'm going to change the color of my pen. Just give me some time to do that. So they tell us that PQ is 2A. Actually, then all the sides are 2A because it's a rhombus. And then they tell you PR is 3 over 2 of PQ. So let's work that out. If they are telling us that PR is equal to 3 over 2 of PQ, so where you got PQ, you're going to put in 2A. You can quickly take your calculators out. 3 over 2 times 2, or you can put it as a fraction, cancel your 2 off, and PR is equal to 3A. Are we in agreement? Yes or no?
Yes,
Right, going into the diagram. Now we're moving to the diagram. Remember, PR is the entire diagonal, which I like to cut in half, to be honest. So if I want to find PT, what would PT actually be?
A half of 3A. So
Okay, everyone is agreeing with that? All right, but anyway, let's go and find out what are we trying to find here. Express QT. Where is QT? QT is there, right? So if I want to find PT, I got to take 3A and divide it by 2. Okay, so if we go to a diagram, we can say PT is equal to 3A over 2. Now the question is to find QT. What would we use? It's a side. What are we going to use to find QT?
diagonals of a rhombus are equal. So, oh no, so
No, diagonals of a rectangle are equal.
Diagonals for rhombus bisect each other.
How is that going to help us, Mr. Pillay?
We can, what do we have? If PR is the whole diagonal, then
Somebody help him out? Nobody? All right, there's your hint. Look at my red triangle. What type of triangle is that?
right angle.
It's a right angle triangle. If ever we work in a right angle triangle, want to find a side, we think of Uncle Pythagoras. You remember your uncle called Pythagoras? You forgot about him? Yes or no? Can you see we
Yes,
need
sir.
to use Pythagoras here? So if I'm trying to find QT, we know QT squared. Now remember 2A will be your hypotenuse. So QT squared will say we'll take the hypotenuse, we're going to square that, and we're going to subtract the other side, which is 3A over 2 all squared. And I need a reason, and my reason is called Pythagoras. So we're going to work that out and say QT squared is equal to 4A squared minus 3 squared is 9, 2 squared is 4, so it's 9 over 4A squared. You can put the A squared on top. All right. So now, to work out what is 4 minus 9 over 4. You can actually use your calculator. No one's going to know that. You can. It didn't tell you not to use a calculator. So we know 4 minus 9 over 4 in our calculator. What is 4 minus 9 over 4? 16 minus 9. What is 16 minus 9? 7. Well, we're getting 7 over 4. Yes or no?
Yes, sir.
All right. Now, to find QT, we got to find the square root of 7 over 4a squared. So we can't find the square root of 7 over 4. So we can leave it in its third form. Sorry, my pen is going a little, losing some ink now. We can find the square root of 4 to be 2, and the square root of a squared is a. So that is our answer. QT is actually equal to root 7 over 2. Or you can just use your calculator, will accept the decimal. If you're struggling, just take your calculator and type in root of 7 over 4. You should get a decimal answer for that. Are we all happy with that? Good question there, Mr. Pillay. Nobody's talking to me. We're all good now.
Yes,
Mr. Reese
sir.
joined us very late today. Mr. Reese, why you came in so late?
So I forgot about the call.
Sorry?
I forgot about the call, sir.
Okay, we're going to the next question, all right? My apologies for this, for the arrows being in the wrong place. Actually, maybe I can move it down right now. Instead of apologizing, let me just sort it out and put it in its right place. How's that, guys? We are trying to prove ABD is congruent to CBD. Do we have three things? Let's look at it. Number one, AB is equal to DC, given. Are we all happy with the first one? Number two, the lines are parallel, so we can say B1. Oh, my pen is letting me down now. Just give me a minute there. All right. Second one is B1 is equal to D1, equal alternate angles. What is number three?
DB is common.
DB is common. Can everyone see DB is common? So we have a case called side, angle, side. And therefore, those two triangles are congruent. I think this is the same question as the previous one. Is this the same question? I don't know. It just sounds very familiar. So the second part of the question is to prove that AB DC is a palm. Actually, that's obvious. That's not a good question. Badly said question. But what would you have said? I would have said AB is equal to DC because that was given. Then I would have said AB is parallel to DC. And why is that so? Anybody knows why it's parallel?
Given.
It was also given.
Congruency.
And therefore it's a palm. And why is it a palm? I'm not writing the whole thing down, therefore it's a palm. What reason am I using?
One pair, opposite sides, equal and parallel.
One pair of opposite sides equal and parallel. Can you see how obvious that question was? That's why I said it wasn't a well-set question, am I right? Because we'll be thinking, hey, there's a catch in this question, but it's actually a straightforward question. Are we moving too fast, too slow? I'm happy to see we have 27 people on board today. That's very good news. All right, let's look at another question. I'm going to give you about 5 minutes to try this one on your own. Go for it. I'm going to now go on mute and I'll come back in 5 minutes while you're trying this question out. All right, I think I gave you enough time to actually look at that question. So the question is to prove that ABGE. So I just want to highlight that. Okay, sorry, let me just erase that line. Okay, we're going to be looking at this figure called ABGE. So I just want to highlight that. So we're going to prove this a palm. Let's see what we know at this stage. It says on the top, the figure below shows palm BCDE. So BCDE. Okay. So the only resemblance or only thing that I can see that could be relevant there, opposite sides are equal. And also opposite sides, the diagonals bisect each other. Okay, so I just want to mark that. We know that the diagonal, sorry, I just want my pen sometimes is. So we know that the diagonals bisect each other, that's equal to that. Okay, we know that. We also know that the opposite sides are equal, opposite sides are parallel. So we can also make a note. That's a palm. That's parallel to that. And then they also tell us that ABCG, let me get a different color out. ABCG, A, B, C, G. If ABCG is a palm, then we can also mark CG is equal to that. Okay. And if that is a palm, we can also say that that line is parallel to that. I actually don't need that, to be honest. So I'm not going to use that. Can't see myself using that. But I can see myself using those two sides are equal. So if you're looking at a diagram now, I just want to highlight the diagram for those of you who cannot see it. They're telling us that that is actually a palm. So we mark those two to be equal. All right, any ideas? How should we do this? The solution
CG is equal to BA because of opposite sides of a palm.
Okay, the solution is actually, that's why I stopped. If you're looking at a diagram now, the solution is actually in front of you, okay? So let me just, before I interact with that. So we know now, if it's a palm, that is equal to that. Opposite sides equal. But then previously, we also proved that this one was equal to the diagonals bisect. So we have BA is already now equal to GE. But we also know that if it's a palm, that line is parallel to that. And now GE is the same line as CG. So therefore, we have a pair of opposite sides equal and parallel. Okay, let me write that down. It's quite tricky. So we started off by saying, all right, CG is actually equal to GE. And the reason why CG was equal to GE, diagonals bisect each other. Then we also said that CG is equal to AB. And the reason there is opposite sides of a palm are equal. So therefore we can conclude, you'll notice that CG is common. Therefore we can conclude that GE is actually equal to AB. So that's the first part we wanted to prove. Then we know that CG is parallel to AB. And the reason there would be opposite sides of a palm are parallel. But now we can also conclude that GE, therefore GE is parallel to AB, because CGE, that's your same line. They're collinear, in other words, all right? And therefore, actually, that's what we want to do. So therefore, it's a palm a pair of opposite sides. They're equal and they parallel, and that's what makes it a pound. Anybody found any other way to work that out? Any comments on this question? Comments? All right, let's go to the kite question. Somebody sent me a message. Where are these questions? It looks familiar. Gentlemen, all these questions are from past papers, all right? I'm pulling them out from past papers, so I'm not making up my own questions, all right? So you would have seen some before. That's why it's called revision. Okay, this is a kite question. So PQRS is a kite. Now we got to know the properties of a kite. Very important to know the properties of a kite. And they want to know what is the length of PQ. Okay, I'm giving you some time to think about it before I actually start to comment. All right, any comments? How do we go about finding OQ?
It's 2 centimeters
Right, it's 2. Why?
because the long diagonal in a kite bisects the short diagonal.
You see how important properties are, gentlemen? If you don't know the property, you're not going to be able to work out geometry. So we know one of the properties of the kite is that the long diagonal bisects the short diagonal. In other words, put it plainly to you, OS is actually equal to QO. Thank you for that answer. Next question, POQ. Can someone tell me what is POQ?
90 degrees.
90. What's my reason for that to be 90?
Diags intersect 90 degrees.
Okay, diagonals intersect at 90 degrees. Actually, diagonals of a kite. I told you, if ever you're confused and you don't know what the reason is, just write down kite or properties of a kite. Sometimes they will accept that. That's only when you don't know now. Don't get, I'm not saying you must do it all the time. So now, we want to find QPS. I'm waiting for you. Tell me what is QPS.
40
So,
degrees.
How did you get 40 degrees?
The long diagonal bisects the vertex angle.
Very good. Okay, so we're going to get our 20 degrees coming in here. And therefore, we have QPS to be 40 degrees. Did you notice that the two small triangles here are actually congruent? Okay. Yes or no? We have a beautiful case of side, 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 because that's a common side. And if you look at the bottom one, they're also congruent. I'm talking about these two triangles, all right? Not that we need to use it, I just wanted to point that out. So how would we find, let's make a question Q1. How would you go about finding Q1?
some angles of a triangle.
Well done. Some angles of a triangle. 180 minus 90 is 90, minus 20 is 70. And we know we have an isosceles triangle that has to be 70. Okay, we're moving on. I just want to look at a different type of questions before I decide to do that one. Okay, I want to go into this question because it's dealing a little bit of a midpoint theorem. Did you do midpoint theorem this year?
Yes, sir.
You did midpoint. The other class, okay, you're not in my class. Did you guys do midpoint theorem this year?
Yes, sir.
All right, so everyone did midpoint
sir.
theorem. So we can do this question. So what does the midpoint theorem, actually, before we go to the midpoint theorem, let's quickly understand the midpoint theorem because we need it for this one. The midpoint theorem basically tells us if we have two midpoints, in other words, that is equal to that and that is equal to that. If we have two midpoints that you see there, what is our conclusion? if M and N are midpoints, what conclusion can we make?
MN is parallel to BC.
Now I'm changing my color because this is our conclusion and it's not part of. All right, if those two are midpoints, it means that line is parallel to that. And also, what else do we know?
MN is half of BC.
Okay, it's half MN is half BC. So that is our midpoint theorem. So now that you know the midpoint theorem, let's look at how we're going to apply it. So all right, let me give you some time. Actually, it's a 1 mark question. Let me not give you time because it looks a little too easy for 1 mark. In the diagram, D is a midpoint. They're telling us that D is a midpoint. Can everyone see that? I'm going to put a dot there of triangle ABC. E is a midpoint. And then they're telling us which DE is equal to EF. Those of you didn't catch that one, let's put it in there. They also tell us that these two lines are parallel. So mark that there. And now, before we even start, if I draw the first triangle, because D and E are midpoint, we can immediately conclude, I'm going to change my color again. If D and E are midpoints, then that means that line has to be parallel to that line. But anyway, write down a reason why ADE is actually congruent to CFE. So I'm going to quickly highlight those two triangles, okay? Let's use a lovely purple. So if I look at ADE, okay, let me get a thicker pen. Now, if I want to prove those two triangles congruent, let's see if we know why they're congruent. So we got a side, as you can see, that was given. Then we can use vertically opposite angles. And we also know AE is equal to EC. So the reason why they're equal is the side angle side case. Write on the reason why DBCF, DBCF, why is that a palm? I actually don't like that question, to be honest, because I would have said, let's prove it's going to be a palm. Okay. So I'm going to actually highlight that one for you. Let's suppose the question is prove it's a palm. Okay, can we prove it's a palm? Any ideas?
AD is equal to CF because of congruent triangles proven, which makes BD also equal to CF.
Hey, that's a quick way, huh? Well done. AD is equal to DB. Okay, for those of you who can't see it, we're going to highlight that one. Because we prove congruent triangles, we know AD is actually equal to CF. But it was given that AD is equal to DB. And can you see now you have BD is equal to CF, and also it's parallel. So you have a pair of opposite sides equal and parallel. I was actually looking at it the other way, to be honest with you. I was looking at DE is parallel to BC. So I was looking at this case, and the whole line is DF. So I was looking at opposite sides parallel. So
Sorry, so
yes.
how did you find that DE is parallel to BC? So
Because of midpoint theorem, they told us D and E are midpoints. Okay. If D and E are midpoints, then the conclusion of the midpoint theorem is DE is parallel to BC. But I don't think they wanted to use that one. Doesn't matter. They wanted you to actually use the congruency. See, that's why they asked you in the previous question, those two triangles are congruent. So what can we conclude? That AD is equal to FC. But AD was also equal. So I like that pair of opposite sides equal and parallel. Now, the last question is, hence prove the theorem which states that DE is equal to half BC. You don't have to prove the theorem. Okay, we have to prove that DE is equal to half BC. Now, basically, we know that. It's coming from the midpoint theorem. All we have to do is the write-up. I would have just said midpoint theorem, but anyway. How would we prove that? So I would say AD is equal to DB, and the reason that that's given. Also, AE is equal to EC, that is given. What I'm actually doing is telling them that D and E are midpoints. And therefore, I can now conclude that DE is equal to half BC, and that is the midpoint theorem. Are you happy with that?
Yes, sir.
All right, and then I want to go to this question. The last question that I'm actually dealing with. See, EX15 means it's coming from the exemplar 2015 paper. All right, let's give you some time to read first. All right, if I read the first question there on this one, it's telling me to prove that SP is equal to QA. So let's quickly get in there. And I just want to, okay, I'm using, let me just change that color. So basically, I want to prove that SP is equal to AQ. I'm actually just going to complete that quad. Okay, so that's what I want to prove. It's a 4-mark question. That means I need to do some work. So let's go to top and read. PQRS is a palm. PQRS. So immediately we know if it's a palm, that side is equal to that. And we know the lines are parallel. It's marked for us. Okay. Are we all happy with that? But then it goes on to tell us that PR and QS, okay, that's a lot of information there. Then they tell us SB is actually equal to BA. Okay, so let's go and read properly again. PQRS is a palm, PQRS. If PQRS is a palm, we know the diagonals also bisect each other. Okay. So I just want to note that. Maybe let me actually quickly highlight that it's a palm for you, okay? For those of you who can't see that. So that's our palm. We know opposite sides are equal. We marked it. We also know that that and that are equal. Bring a V there and a V there to mark it for you. All right, because that's your diagonals bisecting each other. And then they're going on to tell us that SB is equal to BA. So I want to mark that. Let me change my color. So they tell us that SB is equal to BA. All right. And then the first question is equal to SP is equal to QA. How can we prove that SP is equal to QA? Any ideas?
So
Yes.
we can say that SP is equal to QR.
S
And
what?
QR, SP
is equal to QR. Well done.
And QR is equal to QA through the midpoint theorem.
Hey. Young man, tell us a little bit more about this midpoint theorem. How did you get that from the midpoint theorem?
So because they said that SB is equal to B,
Right, we got a
and
midpoint.
then that BQ, B extends to Q.
All right, I'm with you. But it didn't tell us
So,
that
and-
RQ is you see,
So because PQ would be oh my gosh.
I'm seeing what you're saying. You're actually using the converse. You're actually using what we're calling the converse of the midpoint theorem. That's what you're using there. Did everyone see that? Anybody with me? Somebody with me?
No, sir. I'm lost, sir. I can't see the midpoint there. Can you please explain that, sir?
So what this young man is actually telling us, if we look at it in context, so he's looking at this triangle here, correct me if I'm wrong. Okay, he's flipping the triangle the other side, and he's saying, right, B is said to be a midpoint, and we know these lines are parallel. So if we have a midpoint and the lines are parallel, that's our converse, then that means we can conclude that that has to be the midpoint as well. Q is the midpoint. And that's how he got QR is equal to QA. Is that what you're trying to tell me, young man? Where's that young man? I forgot his name. Who was talking to me earlier? Somebody. Hello? Is that making sense? Does everyone understand what I did there now?
Not quite, so.
Okay, the first thing you have to see is we're turning the whole triangle around. The yellow triangle is we're actually basically turning it upside down now. And it was given that SB, we know that SB is equal to BA. That was given. We also know that SR is parallel to PQ because that's a palm. So if we got one midpoint and we got parallel lines, our conclusion, which is the converse of our midpoint theorem here, would be that Q will have to be a midpoint. In other words, RQ is equal to RA. That's a good way to see it. The next question is to prove that SPAQ is a palm. Now, for us to be able to do that, that one is not too bad. If you prove the first one, then we know, if we look at SPQA, we know, actually not we know, we proved. Okay, I should have put two strokes on the other one as well. Okay, now in the previous question, we proved that RQ is equal to QA. But remember, RQ was equal to SP. Let me write that down. Some of you. Okay, so we know in our previous question, we actually proved that SP is equal to QA. And you could say proved above. SP is equal to QA. But we also know, remember the purple one is a palm. So the opposite sides are parallel. But remember QA, RQA, that's the same line. So we can now conclude, let me underline that. We know SP is parallel to RQ, opposite sides of a palm. Therefore, we can conclude that SP is parallel to QA. It's the same line, all right, RQA. Underline that. Therefore, it's a palm, pair of opposite sides equal and parallel. And the last one is to prove that AR, my diagram is quite messed up. AR is actually equal to 4MB. Let me find MB. MB, where are you? Okay, so we actually have to join MB. Now, if we join MB, remember the purple is the palm, it means M is also a midpoint. So now we have a triangle. Okay, let me get another color out. So if we look at this triangle here, so we know those two are midpoints. So if those two are midpoints, we can now conclude, because of the midpoint theorem, let's call MB to be X. If MB is X, what is AQ?
2x.
2x.
Okay, that's the midpoint theorem I'm using there. But what would QR be equal to now?
4x.
Now I asked you QR,
2x.
2x,
Oh,
because
sorry.
QR
2x, sir.
is equal to AQ. So in total, how many X's is AR?
4x.
4x. Okay, and therefore we proved it. Can you see AR is equal to 4x? But remember, what did we call X? MB. So AR is equal to 4MB. All right, we've come to the end of today's session. You can see that was my last diagram on my page. I will put this up on Teams for you to look at it again. It would be good if you could print a copy of this and then work with it again. I will put a hard copy. I don't know if you have access to printers. That's my only problem. Or if you've got an iPad, you screenshot and then you can write on it. All right, any feedback, gentlemen?
Excuse me, sir. So how do we join your team?
How do you join my team? You can't join my team, young man. Only I can accept you into my team. All right. But I will put all this up in your teacher's team. So you must worry them. I'm going to give all the teachers a copy of today's work that I did, the video link as well. All right. So they'll put it up into every class team. Is that making sense?